Hi class, this is Professor Smith. I'm going to be doing a short movie on approximating the standard deviation using the histogram. We don't know the values of the original data. We just know, for example, that there were 5 values between 700 and 750, 5 between 750 and 800, and 15 between 800 and 850, and so on. So what we do is we say, well, let's figure out what we think they could be. And so between 700 and 750, on average, that would represent 725. So I'll make a little tick mark at 725. And so I would say, oh, there's about 5 values that would fall in that region from uh, 750 to 750, 700 to 750, and I'll just say that there's 5 of them. And I'll do the same here. And so halfway between 750 and 800 would be 775. And then here, this was 725. And then we noticed something kind of cool. We noticed that if you go from 700 to 750, that has a width of 50. And I noticed the distance from 725 to 775 is also 50. So each one of these midpoints is you just add 50. So the next one would be 825, add 50, 875, add 50 again, and we would be at 925. So I'm going to create a table showing you the values, the midpoints, and the frequencies. So now I've opened up an Excel spreadsheet to show the table of the values that we've accumulated. 725 was the first midpoint, and we had 5. 775 had 5. 825 had 15. And 875 had 20. And 925 had 5. So we can use that information to come up with a mean. We don't know what the exact values are, but we're going to assume that there were 5 at 725. So we're going to multiply these two numbers together, and then we're going to add them all up and then divide by the total. And just to do a double check, if you add up these frequencies, 5 plus 5 is 10, plus 15 is 25, and then 25 and 25 are 50. And the original problem, there was a sample of 50 bulbs that they stated in the problem that there were 50. So let's go ahead and use the Alex calculator to find the mean. And then I'm going to show you a neat thing that you can do to find the standard deviation. So now I've entered in the values. So I have 5 for the first frequency times the first midpoint of 725. So I have 5 times 725. 5 is the next frequency times 775. 15 times the next midpoint of 825. 20, that frequency, times the midpoint of 875. And then the last one had a frequency of 5 times the midpoint of 925. So if we divide that by 50, and notice I double clicked and it highlighted everything inside the Alex calculator and hit divide by 50. And once I do that, that will give me the mean. So the mean's around 840. And if we look at my data, the mean, you can think of it as a balancing point. And it looks like 840, if I had a little fulcrum here at 840, that would balance those blocks, so to speak. So 840 looks about right. So if I got a mean of 1,000, that would be suspect. It's not even on the axes. So 840 looks about right. Now to find the standard deviation, this is the cool part. You're going to select undo. And the standard deviation is the measure of spread. And so what we're going to do is we're going to figure out how far each of the data values are from 840. So if I take 725 minus 840, and then I want to square that, because if you just do the deviations, they're going to always balance out to give you 0. And so we want to square them to eliminate that zeroing effect of the deviation. So I'm going to square that one, subtract 840, and then square, subtract 840 again, and then square, subtract 840, and then square. Ooh, this is an error, that 840, I messed up there. Slide that over just a smidgen. All right, so I'm going to use my arrow cursor key to cursor over to 840, and I put a parenthesis there. And then we're going to subtract 840 again. and then square, and then subtract 840 one more time. So I'm using the arrow key to cursor over. Minus 840 and then square. So now I have all the squared deviations, and since this is a sample, because it says a sample of 50 bulbs, when we find the sample standard deviation, we had to do that little correction factor of subtracting a 1. And so now I almost have it. This is the variance to find, or pardon me, the sample variance. So now to find this standard deviation, I'm going to double click again. That'll highlight the whole expression and hit the square root key. And that's going to give me the formula for the standard deviation. We're going to hit equals, and let's just double check to make sure I have everything right. 725 minus 840 squared, 775 minus 840 squared, 825 minus 840 squared, 875 minus 840 squared, and 925 minus 840 squared. And then I made sure that the 50 minus 1 is underneath the radical, and then we hit equals. And so then we have 55.558, and they want us to round your answer. Intermediate before, but we didn't do any intermediate. We do it all in one fell swoop because we have this neat calculator. But the final answer, they say round it to 1 decimal place. So at least 1. We're going to do 55.6. So that will give us the estimated of the standard deviation. Let's check to make sure we're right. All right, let's do one more real quick. All right, so the first thing we need to do is find the mean. So it's going to be 9. That's the first frequency, and halfway between 0 and 10 is 5. Next frequency is 9. And then to get the next midpoint, I'm going to add the width, and from 10 to 0 is 10. So add 10 to 5 and you get 15. Or you can visually see that 15 is halfway in between 10 and 20. Plus the next frequency of 18 times 25 plus 6 times 35. And then we're going to double click and divide by, and here it says there's 42 patients. And if we add up those frequencies, 9 plus 9 is 18, 18 and 18 is 36, and 36 and 6 is 42. So we get that 42. So that's going to help us find the mean. So we get, ooh, something's wrong. They usually give you nice numbers. Ah, it's 18, which is so nice that they give us nice numbers. So we know if we made some error. Yeah, that's better, 20. So we get a mean of 20. I'm glad I made that mistake. So we get 18, we get a mean of 20. So I'm going to hit undo, and then I'm going to subtract that 20 from each one of the values, basically the midpoint. So I'm going to subtract 20, and then I'm going to square it, minus 20, and use my cursor, subtract 20, square, and then subtract 20, and then square. And then remember, for the sample standard deviation, we have to add in that correction factor, subtracting that 1. So it's 42 minus 1, or you can write 41. Double click. That highlights the whole expression, and then take the square root. Then we hit equals, and we get 9.9. And they again want us to round our final answer to at least 1 decimal place. So that gives us an answer of 9.9. So I hope this movie on approximating the standard deviation of a data set given a histogram has been helpful. Let's check to make sure I'm correct. And we are. Thank you so much. Bye-bye.